Hello everyone, I'm Ryan, the Worldmaster Sales Director. This time, I'm going to share with you the Worldmaster LoRaWAN. Today's topic will include LR140 LoRaWAN converter and WR322 series LoRaWAN gateway. Demo of the LoRaWAN devices LR and WR322 devices. Next is also a demo about the LoRaWAN in this webinar. We are using the YouTube Live to broadcast during the presentation. If you have any question, please type in the chat room. We will reply after the First of all, I would like to have the recap about the LPWAN, Low Power Wide Range Network. We mentioned that LPWAN is adapted to the longer the distance the transmit with the lower the power the consumption application. This IoT contains the water and the gas metering, sensor monitoring, and the water level and the food management. They are located in the wide range and distributed area with the small data size. In this case, Worldmaster provided the LPWAN connectivity with the different models, and they are the NB-IoT, LoRa, and the LoRaWAN for the options that related to the real usage. Regarding the WR222, it can support the licensed band for the NB-IoT with the SIM card, but sometimes SIM card communication is not preferred. Alternatively, users can consider to the non-licensed band, LoRa and LoRaWAN. Here we have the two models for the LoRa communication. One is the Modbus RTU LoRa agent, LM100 as the LoRa master. Another one is the LoRa and node as the client, LC144. It's the LoRa and node to connect to the end devices such as the sensors, RTU, remote transmit unit, or the meters. They are client and master architecture. As for the LoRaWAN, we got the Modbus RTU to the LoRaWAN converter, LR140. It can convert the Modbus RTU to the LoRaWAN protocol and link to the cloud platforms. And WR322GR-LoRaWAN is the LoRaWAN gateway working with the cloud platform as the SIM master and SIM master OT. Again, the differentials for the network architecture among the NB, LoRa, and the LoRaWAN. For the LoRa and LoRaWAN are the network infrastructure can be decided by the users. If you use the LoRaWAN gateway will be necessary. For the NB-IoT, SIM card service from the operator or a carrier cannot be avoided and the network infrastructure is restricted. And the SIM card fee is needed monthly. For the NB-IoT, it can do the bidirectional communication, control, and monitor. It's similar with the LoRa. However, for the LoRaWAN, it's suitable for the monitor only. According according to the requirement from the customer applications. Users can adapt the proper one. Now we know what differentiates is between the licensed and the non-licensed connectivity. In this page, I also have a brief about the major difference between the LoRa and LoRaWAN of the WAN devices. WAN provide the LoRa and the LoRaWAN devices both. For the LoRa, we have the LC144 and LM100. It can collect the data via the AIO or the RS485. For the LoRaWAN, we have the LR140 to get the data from the end devices over the AIO and the RS485 as well. And the WR322GR series is a LoRaWAN gateway to collect all of the LoRaWAN data. For the LoRa and the LoRaWAN, they are based on the same file layer to do the modularization. In application there, we developed our own stack to communicate. As for the LoRaWAN, it follows open standard, and now our LoRaWAN is belong to the class C. Simplified speaking, LoRa is more like the private protocol, and the LoRaWAN is open standard one. Therefore, LoRaWAN has an ACK mechanism so that it can support the resend and the more secure. LoRaWAN is without the ACK mechanism, but it's faster. However, it still have the risk to have the data lost under the high transmit rate and the speedy transmission applications. Regarding some of the power concerned applications, LoRaWAN is the most suitable than the LoRa because of the sleep mode. LoRaWAN can be set the sleeping period to save more power. The function will be adapted in the future. Back to LoRa. It's used for the cable replacement application, and it also can do the simple analog control in the non-critical application with ACK mechanism. As for the LoRaWAN, it's suitable for the larger network scope and collect the data to the cloud platform with the LoRaWAN protocol. But in this case, analog control by the LoRaWAN is not suitable. In the following slide, we will show you about the features of the LoRaWAN devices. In the following two pages, we're going to talk about today's leading role LR140 LoRaWAN converter and the WR322 series LoRaWAN gateway. Regarding the LR140, it's a converter from the analog input or RS485 with the Modbus RTU to the LoRaWAN. Moreover, we are sharing the same case with the LC and the LM devices. It can convert Modbus RTU to the LoRaWAN and support AES 128-bit data equation. For the security concern, for input, it supports the analog 4 to 20 mA, 0 to 10 voltage, and the 2-wire RS485 in the different channels. You can see 3 3 pins, the power input over there, and antenna. IP40, the protection. User can use the USB port to do the configuration by the LoRaWAN and NodeRED utility. Depends on the interface of the connected devices. User can choose the two-way to connect. LR140 by analog input or output. They are the voltage and the current. LR140 can access the data from the different sensors by the AIO, like pH value, temperature, PM 2.5, or else. We also have the outdoor environment sensor, the ES series for your sub-level. With the Modbus RTU, LR140 will transmit the data to the WR322, the GR, the LoRaWAN gateway by the LoRaWAN protocol. As for the LoRaWAN gateway, there are two models, WR322GR-EC-LTE-LoRaWAN and the WR312GR-EC-LoRaWAN. WR312 support the LoRaWAN LPWAN connectivity in the wireless interface only. For the WR322, it supports not only the LoRaWAN but LTE interface. It built in the LoRaWAN server and support MQTT so that users can use it to connect to the cloud server as the gateway. It also supports the different interface like the serial ports. LTE Cat4 or Cat6 is optional. LoRaWAN and the 2 gigabit Ethernet ports to flexible to build up the application. It also supports the different security way to protect the application from the different steps, such as the OpenVPN and IPsec for the data tunnel, HTTPS and the SSH for the secured login. Moreover, if users can program, it also offers the OpenWRT platform. Users can use the GCC toolchain or NodeRED to develop which the function they will need. Last, users can choose the open cloud platform like AWS, Microsoft, or else, or private the cloud platform provided by the WarMaster, SingMaster, or SingMaster OTA. Here you can see the feature. We collect the sensor data from the sensor by the LoRaWAN. And some environmental data are shown in this picture. They also used it in the analog monitor, not control. In this page, we will set up our topology like this to configure WarMaster devices. In today's LoRaWAN demo, we will show you how to collect the data via the LoRaWAN subnet and bring the list data to the cloud platform SingMaster. Here is how to set up these devices. Later, we will show you how to complete them step by step. Please connect the sensor to the LR140 by the RS485 first. Then, use the USB port to connect to the LR140. Open the WarMaster and NodeRED utility to configure. After complete the setting of the LR140, please use the Ethernet to configure the WR322-EC-LoRaWAN. We'll show you later a step by step. After they finish the setting of the WR322, it will connect to the SIM-mask OTA. Then we can start the demo. Regarding the platform, users can choose the platform or AWS or Azure. It's flexible to update to the other platform. Before moving the demo, please let me explain our platform SIM-mask OTA. SIM-mask OTA is the world-mass cloud platform providing the device's configuration and management. World-master devices will connect to it via the MQTT COAP. This protocol and the users can manage devices or applications over the air. From this GUI, you can see the information are short, just like the signal strength, device location can be customized. You can change each widget to show the sensor data, device the parameters, or something else. Of course, we can set a none also once any change or any threshold. And today we will using it to demo this application. After configuring all of the devices, we can complete a typical architecture about the remote sensor monitor application as here you can see. Additionally, there are some ways to complete the sensor solution by the OneMaster product as well. For example, users can choose the NB-IoT or Cat-M1 connection to collect the data and send to the cloud platform. WR222 can meet this application. However, the SIM card will be necessary, and some of the users don't prefer to limit the infrastructure by the operator. So that the LoRaWAN can be one of your choice to keep the same infrastructure without carriers. Therefore, WR140 with LR140 with WR322 is one of your options. Back to the LoRaWAN. IoT sensor is using the AIO or RS485 to connect to the LR140. Sensor will send the environmental data to the LR140 by the Modbus RTU. LR140 will use the LoRaWAN protocol to the WR322GR. WR322GR will collect all of the data in the LoRaWAN's network and then use the MQTT to the world-mass private cloud platform SIM-mask OTA. Or you can choose the Microsoft, Amazon, Azure. This is the open cloud platform, as I mentioned. Again, monitoring the usage is more preferred, not the control for the LoRaWAN. Now, let's see the demo.
Hello everyone, this is our demo topology today. In the left side of the topology, you can see we have a sensor ES104 and US RS485 connect to LR140. And the LR140 will communication to WR322EC through the LoRaWAN. In the right side is our computer. Use Ethernet cable connect to WR322EC, and the PC will run LoRa utility and the SyncMaster OTA. In the beginning, we will use a USB to micro USB cable connect LR140 and the computer. After connect, LR140 need repowering. Then we open LoRa utility and click the connect button and input the default login name admin and the password admin. And after login, you can see the model name is LR140. First, we go to the RTU tab and input RTU name. For example, ES104, and the select ID is 1, PLC address is 501, and the length is 5. Then click Edit button. You can see it will display in right side. If you use different sensor, you can refer the spec of your sensor. And we can check the countdown time for 1 minute. Then click Set button. It means LR140 will send RTU data to LoRaWAN every minute. Then we go to the LoRaWAN tab and enable OTAA configuration table. Then click Read button in device DEV_EUI and APP_KEY. It will generation string for you. The DEV_EUI means device EUI, and the APP_KEY means the application key. Okay, so our LoRa utility configuration is finished. We keep the LoRa utility windows, don't close it, and unplug the USB to micro USB cable. Remember repowering LR140 again. After boot, LR140 will auto join LoRaWAN gateway WR322EC to send LoRaWAN packet every minute. Okay, now we need add the info of LR140.WR322EC. We need open browser, input WR322EC IP address with port 8088. Then we click LoRaWAN server and click application and click edit application. You can see we have already added application LR140. When you edit application, you need paste the device EUI, the copy from LoRa utility. And we go to the application, devices, activation. We select the OTAA join mode and paste application key, the copy from LoRa utility. Okay, when you paste here, click submit button. Then we go back to the application, device, and if you can see the timestamp in the last seen at, it means the LR140 already connect to WR322EC successful. We can also go to the CryptStack webpage of WR322EC to check the detail. The CryptStack webpage is HTTP with IP address of WR322EC and the port 8080. We click the gateways and click WR322-EC-LoRaWAN-D4 and select the live LoRaWAN friends and wait a minute. You will see the LoRaWAN friend upload by LR140. You can check the timestamp. The LoRaWAN packet is uploaded by LR140 every minute. Okay, next, we will go to the WR322EC NodeRED webpage. The NodeRED page is the HTTP with the IP address of WR322EC with port 1880, and you will directly see the default flow for LR140 and the sensor ES104 and ES101-ES. We will explain how to process MQTT data in NodeRED. In the left, you can see we have dragged a MQTT-in node. We can double-click to edit this node. We need to change the topic. First, the format of topic is application / and the ID of LR140. You can confirm the ID in LoRaWAN server and the application, and you can see the ID is 34. So we back to the NodeRED page. Application /34 / device / and with the device EUI of LR140 and the / and the sharp. Okay, the topic is end. You can confirm the device EUI in LoRaWAN server web page and click application devices. Then you can copy device EUI here, or you can also copy device EUI in LoRa utility. After change, remember click done and deploy. And next, we will drag a debug node here. We can click the pull ring to deactivate the debug node. When we activate the debug node, you can see the debug message display in the right side by click the bug icon. Every time when MQTT-in node receive data from LR140, it will also display in debug windows, so you can see the data received every minute. And next, we have dragged a function code named sensor decoder. The goal of the node is passing the MQTT raw data to select a specific string and transfer it from format base 64 to hex. We have already write a simple code for the user. If you double-click the function code, you can see the simple code like this. It will display in the right side of the PowerPoint page. The simple code will transfer the string data from base 64 to hex. then convert the hex string to decimal value. So you can see the real word 1E02 becomes 54.2. This is the humidity. The blue word D200 becomes 21.0. This is temperature. And the same, we convert the value of PM2.5 and the PM10. Now we back to the NodeRED web page, and we have second debug node named after decoder, and we also active this debug node. So you can see the debug node. The string output by the node by this node after decoder is a readable string. And the last, we have drag and connect a MQTT-out node here, okay, to send the final string to sync master OTA. We double click this node to check the detail. We have a profile named OTA in the server field, and we click the pencil icon to check the detail. So we input server IP address and the port 8883, and we check the enable security connection, and we check the pencil icon again to check the detail. We need upload the certificate file MQTT server.cer here, okay. And in the security, we need copy the access token. Let's copy from the CMS OTA and paste here. Okay, so we go to the CMS OTA page. In the devices, we have created a new device named LR140. And here is the access token of LR140. So we copy here and paste here. Okay, so after configuration, we can update, down, and deploy. And if your configuration is correct, you will see the green icon and connected. Okay, so now we go to the semester OTA. The data already sent from NodeRED to semester OTA. So we click LR140 and we go to the latest telemetry. So you can see the humidity, temperature, PM2.5, PM10, upload, receive data here. So we can see the last update time. It's refresh every minute. Okay, so we can use the receive data to create some widgets in the dashboard. So in the dashboard, we create LR140-demo here. Okay, so you can see we have already added the temperature here. Okay, it's very easy to edit another one. So you can click the pencil icon to enter the edit mode and edit a new widget, and select create new widget, and we select digital cookies. Okay, so for example, we added the humidity, so we can edit, and the parameters we select LR140, and in the time series, we can select the humidity, okay, and edit. So we can drag the icon to change the position of the icon, and we can drag to enlarge the icon. So you can see this is the humidity here. So you can add more widget, okay, as you can, and click apply changes. So you can see this is data received and display in the dashboard for you in the semester OTA.
Okay, here is today's demo and today's topic. Today we introduced the LoRaWAN and related the product WR3212 LR140. So if any question, you can mail to our technical team. Thanks for your time to join. See you next time. Bye.